Hello, everyone. In the last lesson, we learned how to acquire a stable and reliable DC-regulated power supply and produce a single-phase bridge rectifier filter power supply, one of the most used circuits in the DC-regulated power supply. Let's learn about another reliable DC-regulated power supply, producing a series DC-regulated power supply. The lesson requires you to acquire the installation and debugging skills of adjustable DC-regulated power supply by utilizing the provided electronic components and analyzing the structures and working principles of series-regulated circuits. I hope you can read the process document carefully according to the circuit schematic diagram, understand each circuit component structure, function, working principle, and circuit composition structure, and test components and harnessed circuits according to the requirements. This lesson will be divided into 4 parts: preparation of practical training principles, supporting practical knowledge and skills, and consolidation exercises. We will learn them one by one. 1. Preparation of practical training. I think you have become familiar with it already. It is a necessary task before practical training. 1. Relevant rules of the training room. A. Follow the rules of the practical training room and correctly use the instruments and tools. B. Circuit wiring should be reliable and free from soldering defects. C. Always wear personal protective equipment for the practical training, and female students must wear safety helmets. D. Safety electricity rules must be strictly followed. 2. Students are required to prepare tools for practical training. A set of commonly used electrician tools, soldering iron, solder wire, etc. Since you have completed the preparation of practical training, let's start with the schematic diagram for practical training and circuit working principle. The above circuit diagram shows the series DC-regulated power supply. After understanding the circuit diagram, let's learn the analysis and working principle of the series DC-regulated power supply circuits. A. Analysis. What is a power supply circuit? It comprises a 220-volt to 9-volt single-phase transformer, a fuse FU1 with a rated current of 0.5 amperes. The circuit converts single-phase 220-volt AC into 9-volt AC and sends it to the rectifier filtering circuit. What is a rectifier filtering circuit? It consists of 4 IN 4001 diodes V1 to V4 and FU2 and converts the 9-volt AC input from the power transformer into pulsating DC. What is a regulated circuit? It comprises capacitors C2, C3, triode V5, and regulated diode V6. It outputs a relatively stable DC voltage, around 6 volts, on both sides of C3. B. What are its working principles? The power transformer T's secondary low voltage of 9-volt AC is converted into pulsating DC through the rectifiers V1 to V4 and the filter capacitor C1. It is transmitted to the rectifier V5, resistors R1, R2, R3, and silicon diode V6 regulated circuit. At last, a stable 6-volt DC is output on both sides of C3. 1. Crystal triode. A. Introduction. A crystal triode, abbreviated as a transistor, has 3 electrodes, namely base B, collector C, and emitter E. The transistor can be operated in 3 modes: cutoff mode, saturation mode, and active mode. The transistor can amplify current in a circuit. It is an ideal contactless switching component and the core component of the amplifying circuit. There are many types of transistors, which can be divided into silicon transistors and germanium transistors in terms of material. They can be divided into NPN transistors and PNP transistors in terms of internal structure. They can be divided into low-frequency transistors and high-frequency transistors in terms of working frequency. They can be divided into low-power transistors, medium-power transistors, and high-power transistors in terms of dissipative power. Low-power transistor, a transistor with a maximum collector power dissipation of less than 1 watt. Medium-power transistor, a transistor with the maximum collector power dissipation of 1 to 10 watts is mainly used to drive and excite circuits and provide driving signals for power amplifiers. High-power transistor, a transistor with a maximum collector power dissipation of more than 10 watts. The industry standards in China for transistor models consist of 5 parts, as shown in the following example. B. Identification and testing methods of triodes. The shape and pin distribution of a common transistor are shown in the figure. The method for identifying a transistor's pins using a multimeter is as follows. Identification of base electrode. Set the multimeter to R times 100 or R times 1K and use 2 test leads to measure the forward and reverse resistance between every 2 pins. When low-value resistance is measured, either the lead is connected to an electrode or the second lead is connected to the other 2 electrodes successively. The electrode to which the first lead is connected will be base B. It is important to pay attention to the polarity of the multimeter probe. If the red lead is connected to base B while the black lead is connected to either the emitter E or collector C, and a low resistance is indicated, then it can be determined that it is a PNP transistor. If the black lead is connected to base B while the red lead is connected to either the emitter E or collector C and a low resistance is indicated, it can be determined that it is an NPN transistor. Distinguishing collector C from emitter E, taking PNP as an example, set the multimeter to R times 100 or R times 1K, connect the red lead to base B, and connect the black lead to either emitter E or collector C. One of the 2 measured resistance values is larger, and the other is smaller. In a low resistance measurement, the black lead is connected to the collector C. In a high resistance measurement, the black lead is connected to the emitter E. We have learned to read process documents and understand the structure, function, and working principle of each component and circuit composition structure, test components, as well as connect and debug circuits according to the circuit diagram, and through analysis of the structure and working principle of the series regulated power circuit. That concludes this lesson. Thank you, everyone.